Welcome back to my math channel online today. In our video today, I would like to introduce to you the new unit in the course of Pre-Calculus Math 12. And the title of the topics of the lesson we are going to learn today is about exponential and logarithmic function. First of all, I would like to talk about the exponential function first. There are so many characteristics and features, special features, and some very useful application of this exponential function I would like to share with you in our Pre-Calculus Math 12 online. So if you follow my channel online, you can see the lesson well connected together because I am publishing the course online on the detailed lesson, and they are presented to you in the order of the sequence of the mathematics language. So today, in today's lesson, I would like to talk about the exponential function. It could be a good idea to share with you some important concept before I get into the computation and solving problem in the exponential function. So bear with me 1 minute. I'm going to share the screen with you and walk you through one by one. So let me present it to you online so you can okay, so we are at the first slide of the lesson today. So on the first slide, I'm talking about exponential function. The usage of exponential functions can be found in many areas, such as intensity of sound, acidity and alkalinity. If you learn chemistry, you know about this, or earthquake intensity and many more. And on the bar, you can see that there's two functions here, and they are represent the exponential function. We will look into that more details in the couple of slides. So next, I would like to show you the example. The relative loudness of a jet plane 20 meters away compared to the TOH is a threshold of hearing is about 10 to the power 14, and that equivalent to 140 decibel measurement. Next, I would like to show you the application of this, and they have calculated for us. So on the first column, I'm talking about the sound of the type of sound, like rock, concert music, or heavy traffic. The next column is the measurement based on the statistical data, relative loudness compared to the threshold of hearing. And the third column is how the unit were converted into the unit of decibel measurement. So let's take a look at the first row here is the loudness of rock concert music. So it loudness based on base 10 all of this is based on the base 10, and base 10 to power 12 is the loudness compared to the threshold of hearing. Now our threshold of hearing down here is represented by 1, and the decibel measure is 0. So rock concert music have a loudness, it's very loud. It's from 10 to the power of 12, which is 140 decibel. Then heavy traffic is 10 to the power of 9, which is also very loud and represented by 120 decibel. If you hear the sound of the vacuum cleaner, it's about 10 to power 8 and measure in decibel is 80. Our normal conversation loudness is about 10 to the power 5 and convert to 50 decibel. If you whisper to someone's ears and you don't want the next person to hear, then you can reduce the loudness from 10 to the power 2, represent 20 decibel. On the winning day, if you hear the rushing leaves from the trees, this number, this loudness represent about the base 10 to power 1, which is 10 decibel. And all of this is based on compared to the threshold of hearing of the base 1 and with the 0 decibel measurement. So all of this base here to show you all of this calculation and measurement based on the power and the base 10 and based on this number power. And this number power is calculated in number, but if it represented by an X or a Y letter, then we're talking about the exponential function. So let me walk you through the next slide. So in the next slide, I present to on Math 12 student and remind you about what you have learned about the law of exponent in Math 10 and 11. So this we call an exponent properties. And these basic exponent properties is very important for us to solve any exponential equation or transfer into logarithmic. So let's look at the property 1. So property 1, we have a letter B to the power 0. Now the letter B here stands for the base number. There are two components of the power number. The first component is based on the base here. So the base here stands for the short form is B, which is could be the base 10 like we just seen it, or could be base 3 or base 2, whatever it is. That's why we want to put in the general form. The base here represents for any numbers. And the power on top is 0. So regardless what number of the base here, as long as you have a power 0, the number will turn into 1, equivalent to 1. And you can check it on your roughing calculator, on your calculator. So let's say if you have two numbers with the same base, B here, to the power of X, multiply with the same base to power of Y. We represent X and Y because these power can be different number. So for example, B to power X could be 3 to power 5, and B to power Y could be 3 to power 10, something like that. So therefore, the base will be the same, but the X and Y power on the tops are different. And if these two numbers with the same base multiply together, then in terms of the power, we don't multiply them, but we add them. So multiply become addition of the power. Now, because the power is a very big number, right? If you have like 2 to power 16 is a huge number already. So therefore, when you multiply them, it means you add their power with the condition that these numbers have to be the same base. And that's why you see b to the power x times b to the power y, because we're talking about the same base here. Now, these rules, these laws of exponent is not applied for different bases. Keep in mind. Okay, so let's go to the property tree here. In the property trees, we talk about divide the number power. And if you have two numbers with the same base here of b to the power x divided by b to power y, then the law said that in division, we subtract the power. So you can see that it goes logically. It means multiply become addition and divide becomes subtraction, because multiply, which is you make the number bigger and therefore you add. If you divide down, you make a number become smaller and therefore you subtract the power. So the next property we're talking about, if you have a base to the power x, and then you have you power it again by a power y, this property we call a double power property. And in this case, instead of adding them like x plus y on top here, now you will distribute the power outside into the power inside the bracket. So the answer will be equal b to the power x multiplied with y. So this power we call a double power. So you see that the idea is not multiply the power, but it's like you power the first time and you power it again. And that's why now you multiply the power together. Okay, I go to next property, which is b to the minus x power on the top. Now in math, when you have a negative power like that, you can convert this, become a reciprocal fraction, because any base here you can put a 1 underneath it as the represented denominator. So now all what you do is twist the 1 on the top and bring this base down at the bottom. So denominator go on the top and the numerator now go down to the bottom. And that equals 1 over b to the power x. And notice that by doing this, you have no longer to have a negative exponent, because once you bring the base here down at the bottom as a denominator, then equivalent to this action, you change the negative sign of the power become a positive power. And that's why we have to reverse the fraction like this. So let's go to the property 6 here. The property 6 is similar to property 5, but represented by a fraction. So if you have the base on the top is the base a to the negative power x, divide by the base b, which is different base, they're not the same base, divide by b to the negative y. So first we have to change this. First we have to change, sorry, I have to go back and how do I go back? Okay. then I have a, sorry for technical problem. I'm gonna have to go back. Okay, so we are here. So first we have to, oh, I have so much trouble. Sorry. Okay, we get back here. So first you have to twist the, you have to change the position, right? So the letter A here will bring it down and the letter B will bring it up. And why do we do that? The reason, because we want to change the negative power become positive power. So you see like negative y become positive y and negative x become positive x. And because we want to change them, so we have to twist their position. It's just like the inverse function, like property phi. So the A on the numerator become denominator and the B denominator become numerator. So they change the position, and two actions you do at the same time. Once you twist their position, then they should be changed from the negative power become a positive power. Okay, so now I will talk about, I think we still have the same problem. I don't understand why, but sorry about this experience. So I'm gonna, no, I think this, okay, so just bear with me a second. Let's see how it looks like. Okay, so now we get back, and sorry about that. So now I'm talking about the property 7. So property 7, if you have the two number with different base, so let's say one is the number 3, A equal 3 and B equal 5, and then you multiply them together. But also you have a power outside and all of them inside the bracket. Then you would distribute the power outside into each member inside the bracket like this. So this will become A to the power X multiply with B to the power X. So that is property 7. Property 8, if you have two numbers with the same base, A, and one with the different power X, another with the different power Y, then because their base are the same and they have an equal sign between them, it means that their power on the top, X and Y, also must be equal. And it's true, let's say if you have 2 to the power 3, let's say you have 2 to power 3, which is 8, equal 8, then you say 2 to another power is also equal 8 because these two numbers are equal. Then the y here have to be equal to x, which is only to power 3. You cannot have a 2 to power 4 to power 5. Other than that, this equal sign is no valid. So that is about on the exponent properties. We went through it. And keep in mind, these properties are very important for you to perform the operation in solving exponential equation, which is the next lesson we will learn about that. So let's go to the next slide. Now, on the next slide, I am talking about the wraps of exponential function. So if you notice, the left graph here is the exponential growth. We call this is the growth function because it starts here very close. The y function starts from the axis, which is very close to the 0 value. Never touch the x-axis, so it not equal 0, but it's 0.0001 something. And then it keep growing, and it keep growing to positive infinity value. And therefore, this graph we call an exponential growth. And notice the base here have to be bigger than number 1. Because if you have any number with the number 1, then doesn't matter what power it is, it's not going to change. It will just equal 1. And therefore, the base here have to be bigger than 1. And this function represented by f of x equal b to the power x. And as you notice, this function, let's say if you set x equals 0, what happened to the y here? The y have to be equal 1 because any base to the power 0 equal 1. And therefore, the exponential function characteristic is always across the number value of 0 for x and y for 1. So that's a very important characteristic of exponential function. On the next graph, you will see look like these are symmetrical over the y-axis. And that's true because here we're talking about the function is decreasing. So the function on the left increasing, but the function on the right is keep on decreasing. So it formed the positive infinity, it go down, go down, go down, and almost touching the x-axis, which is the y value almost 0, but never hitting the 0. So it's 0.001 something. And why do we have two different graphs like this? Because the first graph represents exponential growth. For example, your money is set into the bank. If you invest it, and then it will be keep growing by the interest of the bank if you don't take out the money. So it keep growing. And in financial perspective, we call this is the compound interest. And if on the left, on the right function, y is decreasing, you're talking about the depreciation of a car value. Let's say you purchase a brand new car is $50,000. And then over the time, over 1 year, 2 years, it's worn out and its value is no longer stay the same. It will keep decreasing as the time went by. So that is the two scenario represent these two functions in the opposite way. You can see that radio reactants like radioactivities like a substance, it will be decay over the times, radioactivities. Okay, so let's go to the next function and see what happened. So on the next slide, I'm talking about the characteristic of the exponential function graph. And pay attention to this because the graph of this is not just two simple graphs like that. It will have a transformation as well. So on the graphs go through the point 0 and 1, 0 for x and 1 for y, and has no x-intercept. And you can see that they're not touching the x-axis. And therefore they don't have an x-intercept. Number 2, the x-axis is a horizontal asymptote with an equation y equals 0. Number 3, when the base bigger than 1, so fx will be equal b to the power x is an increasing function. The function on the left, we just saw. This is the function, right? And when the power is a fraction, which is the value between 0 and 1, for example, the base here could be 1/2 or 1/3 or a quarter. then the base, if the base is a fraction less than 1, or we can represent as the base b as a number, but with the minus power on top. Remember when we learn about the property of the exponent, in this case, we have a negative power. We can bring this down. Let's say b to minus 4 now will become 1 over 4. Let's say b is the base 2 to the power minus 4 will become 1 over 2 to the power positive 4. And therefore, any negative power like this will turn the number become a fraction if we bring it down. So fx is a decreasing function. In that case, fx is a decreasing function, which is the graph on the right. So these are the basic properties of the graph. And in this course, you should know about their property before we actually learning about the function. So let me go through the next slide. The next slide, I'm talking about the transformation of exponential function. As you can see here, y represent the function equal a times with b to the power x plus h plus k. So these are the transformation of the exponential function, which is we already learned in the first unit lesson in the pre-calculus course. The first unit we learn about the transformation of the function. So this is just about the reminder for you, everything we already learned. So it's just like the review. So A is the vertical stretch by a factor of A. And H here stands for horizontal, translate to the left or right by the H. And the K here represent vertical, shift up or down by a K unit. So this, the whole equation here, and you can see that the first equation we're talking about translates to the left. That's why you have x plus h. And the second function, you have x minus h here. It means we will translate to the right. And we shift down, and that's why we have a negative k instead of positive k. If we shift the function up, we will have a positive k. If we shift the function down, we have a negative k. So this is just the review about the transformations of exponential functions. So let's go to the next slide. So you can see that in the next slide, I present to you the 3 different exponential functions. Let's talk about the blue function here in the middle. The blue function in the middle represents the original function of the exponential function. And the base, you notice the base 2. So it starts at the base 2 because we cannot have a base, the base 1. So this is the function 2 to power x. Notice that x is a variable on the top. The power is a variable. And that's why we call it exponential function. Exponential is the same like a power. And we call a function because it's not a number. The x here is a variable, not a number. And this function is 2 to the power of x. As you can see that this function will go to 0 for x and 1 for y here, across the 0 for x and 1 for y. So now let's look at the red function here. The g of x function is the rest function. So this function have a shape exactly increasing like the blue function, except that it will shift up vertically by 3 units. So you can see that the number 1, that the y value across here Now shift up by 3 units. So 1 here, shift to 2 become 1 unit. 2 shift to 3 is 2 unit. And 3 shift to 4 is 3 unit. So 1 shift to 1, 2, 3 unit up. And that is the base point, you can see it. Because the function shift up by 3 units, it means the asymptote of the x-axis here will go up by 3 units as well. So at 0, it go 1, 2, 3. So the asymptote of the x-axis move up by 3 units as well. And therefore, we can actually sketch this function very easily as the way it is. And you can see that from 0 to 1 is a y-intercept. So the new function also from the position of 3 go up to 4 by 1 unit of y across the y-intercept. So let's look at the orange function. The orange function here, the same base to the power x, but instead of shift up by 3 units, now it's shift down by 3 units. So you can see it the similar shape, but the x-axis no longer to be an asymptote, but the asymptote will go down 1, 2, 3 units, and the asymptote at -3. So when you look at this -3, you can imagine where is the asymptote of the function. So this is the very special features of the exponential function. You will see. So if you see the +3 here, then you would know, oh, this is the value of k, which is the asymptote here is +3. And this is -3, so the asymptote here is -3. So that is the very special characteristic of the transformation wraps of exponential functions. So I'm going to go to the next slide to show you. So the next slide, we talk about the transformation wraps of the exponential function again. Now we can have a various transformation, right? So if you look at the basic graph here of the blue graph, so we have a light blue down here, and we have a dark blue up here, and we have the orange function here. So let's talking about the light blue function. So the light blue function doesn't across the y-axis intercept at 1 like any other function. The reason because you see here, the base of this function is 4 instead of 2. So the function already draw in a steeper slope. And also you have a vertical stretch in front of it, which is you multiply with 3. So the y-intercept 1 times 3, it becomes 3. So therefore this function across the y-axis as the value of 3 because of this vertical stretch. So 1 times 3 becomes 3. So that is obviously is the blue function, the light blue here. Now let's take a look at the dark blue. The dark blue is instead of the base is 4 like this, the base of the dark blue is the base 2, the base 2. And therefore, because the base here is smaller than the light blue, so if the base, if the function of the light blue is have a very steep slope, but because this base is smaller, so the slope is not as steep as the light one. Now let's go through the orange function here. The orange function show us the base here is 1/4. So instead of 4/1 like the light blue function, it twists it reverse inverse 1/4. And it means that we have a negative of x, except because we change the fraction, so therefore we keep as a positive x. But notice the base here is between the value of 0 and 1, and therefore it no longer to be a row function, but is a decay function. So it decreasing function instead. So this orange function is a decay function because the base here is a tiny fraction, 1/4. Again, because we multiply with the factor of 3 for vertical, therefore instead of 1, it will become 3. So on the function across the y-intercept at the number 3 value. Okay, so let me explain the next slide. So here is another type of transformation you will see from the exponential function. So here is the basic function y equal to 2 to the power x, and across the y-axis is 1. This function, this dotted function, is reflection down here become y equal -2 to the power x. So when you have a negative in front of the base, it means that the reflection over the axis. So any point here will reflect down here. So the 1 become -1. So these 2 points right here reflect, 1 become -1. And let's say you pick a point here is at 4, will reflect down here become -4. So that is the reflection function. Now also there is a reflection, but also shift to the right by 3 units. So that's why you see the power here, the base, the -2 base here have an x power, but it moved to the right by 3 units. So any point on this function will move 3 units to the right. So at 2, move to 3 units, you add 3 units, become 5. So this point at 2, at the value of 2 of x, become 5 of the x value right here. So any point on this function just shift to the right by 3 units. So that is a transformation. Now let's check the next one. So the next slide, I'm talking about the application of exponential functions. So let's take a look at the application of it. Exponential function application are found in all aspects of life, such as radioactive decay, spread of a pandemic, a compound interest, etc. And I give you the 2 examples here. Example, what is the initial investment is needed to become a millionaire in 25 years? That sounds interesting. Everybody wants to become a millionaire. If you receive interest at 12% compounded quarterly. So to learn, after you learn this lesson about exponential function, you will be able to answer this kind of question like this. Example 2, if an earthquake in San Francisco had an amplitude of 1,000 times larger than an earthquake that measured 4.9 on the Richter scale, what would the San Francisco earthquake measure? So after you learn this function with me in this unit, and I will show you how to do the computation and solve the problem on the board. As I just want to present this PowerPoint so that you catch your attention, is look attractive for our lesson, And these are the key components I presented to you in our course. So you will be able to solve on this interesting question after you learn this lesson with me. So if anyone interested, please register to my course online. Okay, next I will show you the conclusion of our presentation today. The conclusion is this MS PowerPoint presentation gives you some important key concepts about the characteristic of exponential wraps, as well as the knowledge base about the exponent functions. As you follow the instructor along with this unit study, you will be able to solve various exponential equations, both algebraically and graphically. Besides, you will learn problem solving involving exponential function applications. So stay tuned for much more interesting of logarithmic functions coming next after this session. So that's all about my purpose of present to you about the new unit of exponential function that you will learn with me throughout our online course. And I try to make the course look more attractive to you, look more interesting to you with on my PowerPoint presentation like this. And I will guide you through how to solve problem solving, how to sketch the transformation of the exponential function in the next few video lesson. And all of this probably we have already learned in Math 10, but this is the chance for you to review because most of us, we learn and we forget. And that happened to everybody. The motor skill, you don't forget. Like if you learn how to swim, you never can forget. Even though 20 years after you jump into swimming pool, you still be able to swim. But the academic skill, you got to up to date with it, keep up with it every single day, review and rehearsal so that you don't forget. So that is about very much about my online presentation to you for the unit. I believe this is the unit 5 of our course, exponential function. And so here you see my ugly face again. So I hope that you enjoy my video presentation today throughout the course. I just try to make variety in a different way. Sometimes I do it on the PowerPoint presentation. Sometimes I explain the lesson on usually on the board because that is a place to show you more. Like for me, it's appeal is better, and I don't have to struggle with on the typing of the math notation. Like math notation typing is not easy like we type English or history on the screen. And that's why I have to show you on my whiteboard. For the lesson today, I would like to share with you some important keys about the function we are going to learn. So stay tuned for our next video. Our next lesson will be about solving exponential equation. Thank you for watching and have a good day, everyone. Bye for now.